All right, hello everyone. Welcome, welcome. Yeah, this is our last sort of lecture, I guess, slash review session. Not introducing any new material today because we are getting ready for our third exam, which is coming up later on this week. I'm going to talk about that in just a moment, but before I do, just a quick little review of the calendar just to make sure everybody knows what's left as far as this class goes. This week, really the only thing that, really the only thing that matters is the exam. I just noticed I had quiz 9 due here. Actually, I'm going to move that back to next week because that's when the next assignment is due. So assignment 9 and quiz 9 I'm going to move back to next week as well. The only thing that you have to worry about for this class this week is exam 3, which is on Thursday evening. Notice that on Wednesday, there's no studio. We have one studio left. It's actually next week as well. There's no homework assignment due this week. So the last homework assignment is due next week. Although assignment 9 is over material that is going to be on the exam. So I highly encourage you to start working on that assignment. It is very good practice, very good studying for the exam. The assumption is kind of that you've got assignment 9 done before the exam, but I'm just trying to be flexible, just trying to give people as much time because I know it's a crazy time of year. I'm also drowning under a lot of work right now, as I'm sure a lot of you are. So yeah, one more assignment, one more studio, one more quiz, and one more exam for most of you. And then should you choose to, the final exam is down here on May 2nd. Of course, a lot of you are probably going to wait and see how you do on exam 3 before making that decision on the final exam or not. I'm hoping to have exam 3 grades back, Monday or Tuesday of next week. And this, 1 week from today, on Monday, even though there's no review session, there's no new material, I'll still be here on Monday if you want to come turn in assignment 9 or get help on assignment 9. I imagine those will probably be the biggest concerns that people have at that point in time, but if you want to come talk about your exam or anything like that, I will be here next Monday, but there's no new material. I'm not going to be talking or anything like that. It's just basically office hours for y'all to come get some help, wrapping up the few things that remain for this class. Just want to say one more time too, I've been trying to advertise this. I know it's a busy time of year. We're all overloaded. If a few extra late coupons will help you out on assignment 8 or assignment 9, please let me know. That is a very easy thing for me to do. I'm happy to do that for you if it'll buy you a few extra days and help make your schedule a little bit easier to navigate through. I don't want you all to feel too overloaded about stuff. But yeah, does anybody have any questions about what's remaining on the schedule for these next couple of weeks before we switch gears and talk about the exam that's coming up on Thursday? Yeah?
Can we demo on Wednesday?
Yes, TAs will be there. If you want to demo assignment 9 on Wednesday, actually assignment 8 would be the last day. You could demo assignment 8 with late coupons. It's on Wednesday. All of that should be doable in the labs on Wednesday. Yes, absolutely. The TAs will be there to assist you with whatever you want. But there's no studio. There's nothing due. So, use that time however is best for you. Any other questions before we hop into exam stuff? All right, great. Then let's talk about exam 3. Gonna, just review these logistics one more time, even though I know we've done this a couple times. Hopefully you're already familiar with how this works. The big thing to keep in mind is that your room is going to be the same room that you've gone to take the last couple of exams. So please go to the same room that you've been taking the exams in. That should not have changed. This should be the exact same chart that was on the past exams. Just like the past exams, you are allowed to bring a sheet of paper with you to fill up with notes of your choosing to help you get through this exam. And just like the last 2 exams, this exam is only over the last 3 modules of material that we covered. However, those are pretty hefty modules, right? So let's start with a little bit of maybe basic review, vocab review, I guess, for some of these modules, starting with module 7. So on module 7, this is when we introduced objects. That was a big shift for us. Before we got to module 7, we had methods, and before that we didn't even really have methods. We just had loops and if statements and stuff. So introducing objects, introducing classes was a very big shift for us. What are the 2 kinds of things that you expect to find in a class? There's 2 basic categories of things. Somebody give me one of those 2 categories of things. Yeah? Instance variables, good. Yeah, so instance variables are usually set up right at the top of the class. Those are the attributes, the properties. The relationship that I used to describe that is has a, right? So student has a name, student has an ID number, your student has a major. Those all make sense, right? What's the other category of thing that I expect to find in a class? Yeah. Methods, good. That's right. So the two categories of things are instance variables. Those describe the properties of a class. And then the methods describe what the class can do. So methods should be thought of as actions, should be thought of as verbs, behaviors that you want your object to be able to perform. And then another big concept to keep in mind for Module 7, as well as all the modules actually, is this idea that a class by itself doesn't do anything. In order to effectively use that class, we have to create, what's that called? When I create a version of a specific version of the class, it starts with an I. Yeah, it's an instance. We have to create an instance of the class. How do we do that? How do we create an instance of a class? With the constructor. So all classes are going to have constructors, and constructors are used to create instances of the class. Good. And then in Module 8, we shifted, we took our object ideas and we added some additional concepts onto them. We talked about inheritance with Module 8. So this idea that, the idea behind inheritance is that if I have multiple objects and that are related to each other, right, I can take the shared stuff across those classes and put it in one class. This is typically what we call the base class. And then we can use inheritance to share that base class to all of the derived classes or inherited classes. What is the keyword that I expect to see if inheritance is in use? I know inheritance is being used when somebody types the word extends. Good. Extends is the word that we're looking for. So when we extend a class, we're saying that all of the instance variables and all of the methods from that base class, from the class that we are extending, now belong to this inherited class, belong to this derived class. We can then add additional instance variables if we want to, but then if we want to refer back to the base class at any point in time, such as in the constructor, which we obviously do, and we'll see here in just a bit, what's that word that we use to refer back to the base class in our code? Starts with an S. Super, yeah, that's the one. So we often use super to call the constructor of the base class. That's actually a necessary step when dealing with objects and inheritance, but we also can choose to use the super keyword to call methods from the base class, for example, if we want to. Or anytime we want to refer to the base class, we can use the super keyword. Cool. And then there's one other important concept with inheritance, this idea that, yes, I do inherit all of the instance variables and all of the methods, but let's say that there's one method that I don't really like, or it doesn't actually work the way that I need it to after I inherit it. What can I do if I want to choose to change the behavior of one of my inherited methods?
Override.
We can override it. That's right. Overriding a method means that I am discarding the version that I inherited and providing a new version. This allows us to have some flexibility with the methods themselves, so we're not necessarily forced to take all of the inherited methods. We can choose to provide a new implementation should it be appropriate for us to do so. The last module, Module 9, dealt with some additional data structures, some additional data types, abstract data types. This is meant as sort of a lead-in to 247, the next big class after this class, for those of you continuing your computer science learning after this class is over. The two big data structures that we looked at are lists and maps. So lists are very much like arrays, but there are some differences. Can somebody tell me a difference between a list and an array? Yeah.
Lists can be changed in size.
Yeah, so that was actually a good thing about lists. With arrays, if I declare an array and there's 10 things in it, that array forever has 10 things in it, right? I can't grow an array or shrink an array. I can make new ones that are bigger or smaller if I want to, but I can't actually resize an existing array. Whereas lists don't have that problem. That's actually one of the nice things about them. they are as big as they need to be. So if I add items to it, the list will grow. If I take items off of the list will shrink. It just automatically updates its size as necessary. There's one other big key difference between lists and arrays that I care about. That's also related to Module 7 and Module 8 that we've been talking about. Kind of the reoccurring theme, I guess, of this exam. Lists are that thing that starts with an O. Yeah, they're objects. They're objects. So in order to use lists, it's not that square bracket syntax anymore, right? If I'm using lists, they are objects. So I need to call the constructor to create an instance of a list, and then I need to call methods upon those instances, just like I would for any other object. Other than that, lists do behave somewhat similarly to arrays in that they have an index for all of the values, starting at 0 and counting up, just like we're used to with arrays. So we say that lists are ordered, whereas the other data type, the other data structure that we looked at, maps, is kind of different. How's the data stored within a map? Maps don't use indices, right? What's the term that we use to describe the things that are stored in a map? There's actually two things. Yeah.
Key value match.
Key value pairs is the term. Yeah, so instead of using an index, instead of just saying I'm going to start from 0 and then go 1, 2, 3, 4, maps essentially let you create your own index. So could be a number, but it doesn't have to be. It could actually be a string, or it could be another object, right? It's actually extremely flexible. So now we have the ability to match values not with an index, but with a key. So maps store things in key value pairs. And there's two main operations that we use with maps in order to get stuff into the map. That's going to be the put operation. And then to retrieve stuff out of the map, I believe that is the get operation. But I would like to remind you all too, since we're on the topic of lists and maps, on the upcoming exam that you're going to be taking on Thursday, the very last sheet of it is going to be not an entire list of everything that lists and maps can do, but a condensed list, an abbreviated list of what lists and maps can do. It'll contain everything that you need to complete the exam. So I will show you a list of methods. The idea is that the exam is hopefully not the first time you're seeing these methods or using these methods or thinking about these methods. Just want to make sure that you know that reference sheet will be provided to you. So you don't have to clutter up your own sheet by writing down, map.get and map.put. That information is provided to you on the exam. Cool. All right. That's sort of my little mini review for these modules. I did want to make sure you're aware of the fact that there is a practice quiz and coding problems posted for these modules, just like there were for the past exams. If I can get Canvas to load here. Here we go. So there's a practice quiz and a coding prep with code reading and code writing problems. We have about an hour and change left to go in class, and so with that remaining time, I would love to go through some practice problems with you. I've got the coding repository. That's not it. I've got the coding repository already loaded up in Eclipse with all the code reading and code writing questions. I'm hoping that somebody will have one or two that they want me to see. They want to see me go through. Yes, in the very back.
Yeah, could you go over just writing the constructor for the exam code writing 4 with the car?
Okay.
How to know, because it says only use 2 parameters.
Yeah, let's talk about it.
It's like how to know which parameters.
Yeah. I would love to do this whole problem. I know you only asked about the constructor, but I would love to do this whole problem just to kind of work through a good example. There's no inheritance here, and actually that's another kind of thing I want to make sure to point out to you all. Yes, we covered inheritance. No, inheritance will not be used on every problem. We did a significant amount of stuff in the last 3 modules without inheritance at all. So don't feel like you need to force inheritance into a situation. I'm usually pretty clear on the exam. I'll usually say something, when inheritance is being used. And if you don't see me specifically mention that on the problem, then don't worry about inheritance. Don't try to force the super keyword in if you don't need to. This is definitely an example that does not use inheritance, although hopefully we'll go through an inheritance problem a little bit later on. But let's talk about how to do this problem. There are here's the description of the car class, and here's that phrase used directly. That should hopefully, if you see that on the exam, set off some alarm bells in your brain, right? Has a. That is a direct relationship between an object and the instance variables that it contains. So we're going to have, it looks like, 1, 2, 3, 4 instance variables here. One for the odometer, one for the fuel efficiency, one for the fuel tank, and one for the current amount of fuel that a car has. So when declaring instance variables, the first thing I'm going to type is private. Yes, they all need to be marked private. Absolutely need to be marked private. After that, it's just a variable declaration. So if I'm trying to do, an odometer that tracks how many miles this car has been driven, I think an int is fine. If you want to argue a double, I also would accept that, right? I'm not going to be that picky about it. A string, not so good. But int, double, no problems there. For the next one, fuel efficiency, typically given as miles per gallon. So that one I think probably should be a double. I think that one's probably more accurately represented as a double. Although I wouldn't be terribly unhappy if you used an int for that one as well. The fuel tank, so this is really how big the fuel is, right? So is it 15-gallon tank? Is it a 10-gallon tank? Again, I think double is perhaps appropriate here, but still wouldn't be unhappy if you used an int. I'm saying, I'm not calling it fuel tank. I'm calling it something a little bit different, just to kind of help my brain wrap my brain around it. And then lastly, we have the current amount of fuel. All right. So we have 4 instance variables here. One for each of the concepts that was mentioned here. And that should be always a one-to-one. If I tell you a blank has a, and then list off 4 different things, in your mind I want to think, all right, there should be 4 different instance variables here to represent these 4 different things. It's almost always going to be a one-to-one relationship. Now let's talk about the constructor. It says, for full credit, the constructor should only use 2 parameters, but let's talk about what the role of the constructor is. The constructor's job is to make sure that all of these instance variables are set. So it says I can only have 2 parameters. How can I set 4 values if I only have 2 parameters? Well, let's talk about that. We need to think about, do I know what these values are going to be? If I just create a car for the very first time, do I know what any of these values are? I would argue that yes, if I create a brand new car for the very first time, the miles driven should be 0. I don't need a parameter for that one. It's a new car. It's a brand new car, right? So miles driven should be 0. I think the other one that you could say is not necessary for us to take in is the amount of fuel that it has, right? If it's a brand new car, the tank is probably empty, would be my guess, and somebody's gonna have to fill it up before they can drive it around. But that's the question that you should be asking yourself. The question you should be asking yourself is, all right, if this is a brand new thing, is there a known value that all cars are going to have for this instance variable? Right? If the answer is yes, then you don't need a parameter for it. So these 2 don't need parameters, but these 2 do. Think about it. This is going to change from car to car, very much so, right? The miles per gallon on my Toyota Highlander is much different than, your Honda Fit. They're very different cars. So they're going to have different miles per gallon. I can't just say all cars that get created are going to get 10 miles to the gallon. I don't know that. You have to tell me what kind of car you're creating so that I can make sure that's set up properly. Same thing for the gas tank, right? That depends on the car. So I think those 2 are going to be my parameters. And we're now ready to start writing this constructor. The name of the constructor has to be the same as the name of the class that we're in. So public car, I'll take in double MPG and double, fuel tank size or something like that. And now we can set our variables, our instance variables. Remember, the role of the constructor is to make sure that all 4 of these instance variables get set. So if I have 4 instance variables, I expect to see 4 assignment statements here, 1 for each of them. So this miles driven we said is going to start out at 0. This miles per gallon will be the value that we were given. This max fuel is going to be equal to the fuel tank size, since that's what that means. And then finally, this current fuel is also going to be set to 0, right? Empty tank. If you wanted to be really nice, I did see some people on this exam problem say, I'm going to set it to be full. Okay, I don't have a problem with that, right? You could set the gas tank to be full if you want to. This is an important part of the constructor, and we did talk about this. There are 2 ways that we can set instance variables. One is via parameter, and one is via just some known value. All cars that I create are going to have this for the initial value of the instance variable. Any questions on this before? I do want to come down here and take a look at these 3 methods as well, but any questions on the instance variables and the constructor before I do that? Often go hand in hand. Okay, so the next methods that are here, actually I'm going to skip drive for a second because we can take a look at some of this easy one first. Get miles driven. We have a name for this. Starts with that key, those 3 letters, right? Getters, and their complement setters. Usually pretty straightforward methods. Usually not terribly tricky ones to write, and this is the case here. It says get miles driven. I'm really just asking to return this value. So this is the easiest one. I'll say return this miles driven to take care of this method. And now let's take a look at this one. This one I think is a bit tricky. It says we're going to drive the car. We're going to drive the car this fast for this long, and we want to think about how that's going to impact all of the instance variables that we have, right? So if I drive the car this fast for this long, that's going to increase the number of miles that I've driven, correct? But it's also going to decrease the amount of gas that I have in the tank, correct? But there's another issue. It says for the given amount of time or until out of fuel. So there's no guarantee that we'll actually be able to drive this full distance. We actually have to check first and see if we have enough gas to do it in the tank before we can do that. So first, let's figure out how much gas it would require us to drive this far, and then compare that against how much gas we have. And that'll dictate how far we can actually go. So, all right, we have to do some math here, but it's arithmetic. It's not, complicated math. If I'm driving 10 miles an hour for 1 hour, that's going to make me go 10 miles, right? If I'm driving 10 miles an hour for 2 miles, that would be 20. So I just need to multiply these 2 values together to get the total number of miles I'm trying to drive. So attempted miles is equal to miles per hour times the number of hours. Oh, it's angry because this should be a double, not an int. My bad. Once I know how far I'm going, so if I know I'm going 100 miles, right, and I get 20 miles to the gallon, for example, then I should be able to figure out that I need 5 gallons to go 100 miles. So that means I need to divide this by my miles per gallon to get how many gallons of gas I would need to perform this trip. So gas needed would be attempted miles divided by this miles per gallon. And now that we know how much gas is needed, we can compare that against how much gas we have. And there's 2 outcomes. Either we have enough gas to make the trip, or we don't. So if the gas needed is less than the amount of gas that we have in our gas tank, that means I can drive the full limit, right? I can drive the full amount. So that means I need to increase the miles driven, and I need to decrease the current fuel. So this dot miles driven is going to go up by our attempted miles, and this dot fuel, current fuel, is going to go down by the amount of gas that is needed. Does everybody see why both of these statements are necessary to reflect our driving? That's kind of the reason why this hint is here. Carefully consider the impact of in driving to all instance variables. Well, the miles per gallon doesn't change, right? And the size of the fuel tank, that doesn't change. Those are just, they are what they are. But the amount of miles I drive and the amount of fuel I have changes all the time. All the time. Question in the back. Your instinct is to return? Well, first off, notice that the return type here is void, so I'm not going to be returning anything. And actually, with objects, returning becomes a lot less necessary. Instead, we are manipulating the objects themselves. We're thinking about how the behaviors that we are performing affect the instance variables and manipulating them themselves. So I'm not going to say that you'll never need to return anything on this exam, but manipulating the instance variables is much more common at this point in our coding careers. Any other questions? I'm not done with this yet. I still have to figure out the other part of it. So otherwise, think about what this means. This means we don't have enough gas, but it wants us to drive until we're out of fuel. So it wants us to use however much gas we have in the tank. So now we kind of have to figure out the opposite. How far can I go with the amount of gas that I do have? So, okay. The amount of gas that I have multiplied by the miles per gallon should tell me roughly how far I can go, right? So double actual miles is going to be equal to this dot miles per gallon times the number of gallons that I have. Once we have the actual miles, we can add that onto our odometer. And then since we are using all of the gas, setting the current fuel is actually pretty easy. We can just set that to be 0. We've used it all. I'm draining the tank. This is a bit of a complicated method, I have to admit. This is, I think, one of the harder ones, I think, to reason about out of all of the practice problems that I gave to you. So if you understand this particular problem, I'd say you're in pretty good shape. This is one of the trickier ones. I do think it is in a good position right now. Does anybody have any questions about what I've attempted? There is still one more down here, but any questions about the drive method before we take a look at the next one? Next one has kind of a similar issue. It's here we're adding fuel to the tank. And so it says add fuel to the tank as long as it doesn't exceed the tank's capacity. And this time we do have a return type. You can see this, the return value of double. It wants us to return however much fuel couldn't be added. So if I have too much gas, right, I'm going to give you back the extra. Say I don't need it. So we again have kind of two ways to go. Either I can fit all of the gas in the tank, it all fits, or I can't. I have too much gas and I have to figure out, how much to give back to you. So again, I think, you could use an if statement here to pull this off. If the current fuel plus gallons, which is how much we're trying to put in, if that is greater than the maximum amount of fuel, meaning that there's too much gas, So if we hit this case, there's too much. Otherwise, so if we're in the else, that means all fuel will fit. Actually, I think this might be the easier one to think about. If all of the fuel is going to fit, then we can just go ahead and say this dot current fuel plus equals gallons and be done with it, right? Up here, we have to be a little bit more careful. We have to say this dot current fuel is equal to, well, it's going to be filled all the way up, right? I have too much gas, so I'm going to fill it all the way up to the maximum amount. But how much do I have left over? So we haven't done this return statement yet. How much do I have left over? Actually, we might need to do that math before we fill up the tank, right? I need to figure out, let's see, double leftover. What's the easiest math to do for that? We can do it's the number of gallons that fit. It's the number of gallons we're trying to put in the tank minus the number of gallons that will actually fit in the tank, which is max fuel minus current fuel. Right? And then we'll return the leftover here. Oh, shoot. For this one, we don't have any leftover. It all fits, so we can just return 0. But it is important to note that I do need a return statement for both of these. We can't forget to leave that return statement off. So here I computed how much extra gas I have, how much leftover fuel I have, set the fuel tank to be the maximum, since I know I'll be able to fill it up, and then just return the leftovers. For this one, all the gas fits, so I just put it in the gas tank and then say that I don't have any leftovers. I think I did it, but I see a question in the back.
Yeah, why did you do max fuel minus current fuel instead of like this dot max fuel minus this dot current fuel?
Yeah, so if to truthfully answer your question of why, I was trying to speed things up.
Oh, okay.
But to get to a more, perhaps relevant question, this is not required. I don't have to put this out in front of instance variables. I kind of am in the habit of doing it. That's why you actually see me do it more often than not. My brain has been mostly trained to use this dot out in front of our instance variables. It is not required. You can take it off and notice that it's still blue. It still works. There's one exception, though, where we absolutely do need to put this out in front, which, consider if I have two variables with the same name. So this is a very much separate variable from this. That's very possible. And in that case, I need to specify which one I'm referring to by either using this dot or not. If I take it off in this case, you'll see that it actually is not referring to the instance variable anymore. It's referring to this one. So only when we have ambiguity is it necessary, but I think it's a good idea to do it anyway, just so that you never have any ambiguity. It's always clear. If I see this dot out in front, I know that's an instance variable. But like everybody else, I take shortcuts sometimes, and that's what I did here. Yeah, good question. Was there another question? Thought I saw a hand. No? This is the end of this one. And as I mentioned, I think as far as the code writing problems go, this is one of the trickier ones. If you took a stab at this and got pretty far, you should be feeling pretty good about the exam, in my opinion. I think this is a good example of certainly the kinds of concepts you'll see on the exam. So you won't see this exact problem on the exam, of course. Any final questions on this one before we take a look at another problem? Any suggestions of where to go next? Oh, lots of hands. Go ahead.
Can you do question 5?
Oh, you said question 5?
Yeah.
Okay. I'll get to you next. Yeah. I believe this is the inheritance one that is in here. right? So I was pretty much expecting to do this one. That's totally a great idea. For this first one, we have a computer class. Specifically, we're interested in keeping track of whether the computer's on, off, or in sleep mode. And for this one, we actually gave you the instance variables, so you don't have to tell me what the instance variables are. You've been given the instance variables. You can see there's two Boolean values, one for whether it's on and one for whether it is asleep or not. And now they want you to, just like we did last time, write the constructor. So whenever you're faced with that, be careful not to put a return type here, right? Constructors don't have a return type. That's one of the ways that we can actually tell that it's a constructor and not just a regular variable. The question is similar to what we talked about last time. Do we need any parameters for this constructor? That is always going to be one of the tricky parts of writing the constructor. It says here, when a computer is created, it should be completely off. So I think there might be a little bit of ambiguity the way that this is written here, but to me, if it's asleep, it's not off, right? If my computer just has the screen off, it's still on, it's just asleep, right? So to me, it suggests that both of these should be false. They should be off, 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 off. So I don't know that we need any parameters. I think we can just set both of these to be false to satisfy this one. The computer is completely off. Yes?
Could you repeat when you wouldn't need parameters for the constructor?
If you know what the instance values should be, then you don't need the parameters. Here it tells me when a computer is created, it should be completely off. How do I know a computer is off? Because this is false, right?
Okay. And it would be like when you're creating like a new computer. And it's just like...
Correct. Constructors are always for new things. Yes. Yep. Creating a new instance. Yep. Let's take a look at some of the rest of these. We actually haven't, this is the base class, so we're not actually going to get to any inheritance until we take a look at the next class, but let's do this one first, and then we'll go take a look at the inheritance stuff a bit later on. Here we see there's a method for pushing the power button. So you all, I'm assuming, kind of know how computers work, right? If I push the button real quick, it doesn't turn my computer off, it just turns the screen off, right? If I want to turn the computer all the way off, you have to hold that button down. So the distinction is, did I push it quickly or did I push it down for a long time? And you can see that we've been given this parameter that it'll be true if I push the button for a long time, and it will be false if I only push the button for a small amount of time. And that's only if the computer is on. If the computer is off, right, then we have slightly different functionality. So really, our behavior depends upon a few different things, whether the computer's on or not, and also how long we push the button for. We're going to need some if statements to do this. All right, but if you take a look at the instructions here, it kind of tells you what to do. If the button press is short, the computer should go to sleep, but remain on. Okay, so if long press is false, I'm sorry, yeah, if the long press is false, short press. If the computer is the computer should go to sleep but remain on, yeah. So if this dot is on is true, we're just going to flip the is asleep. If it's true, it should be false. If it's false, it should be true. Everybody with me on that one? Sorry, let me just make sure we're all on the same page here. If I push the button for a short amount of time, it depends whether or not the computer's on or not. So if it's a short press and the computer's on, then I'm either going to put it to sleep or I'm going to wake it up. I'm just flipping that sign. I think the easiest way to say this is to say this dot is asleep is equal to not this dot is asleep. So if it was false, now it will be true. If it was true, now it will be false. Everybody with me on that one? There are other ways you can do it, of course. I think this is one of the quicker ways to do it. Otherwise, that means the computer is off. So if the computer is off, it actually doesn't say to do anything, right? For a short press. So we can just ignore that, actually. We can ignore that situation and move on to the other case. If the button press is long, then the computer should turn off, unless it's already off, or it should turn on. This is actually the same thing, actually, as this statement, just with the other instance variable. So I would say something like this dot is on is equal to not this dot is on. If it was off and I push the button for a long time, then it will be on. And if it's already on and I push the button for a long time, then it's going to go the other way. Are there any questions so far about this? I think this will do it. I'm trying to think if I forgot any situations, but I don't think that I did. Notice that in this situation, if I push the button for a short period of time and the computer is off, nothing happens. I don't necessarily have a problem with that. Not all computers work that way, but that was the way that this particular problem was set up. So I think that if we're going based on these instructions, this is going to accomplish the task. Down here are the getters and setters. These were actually already given to you. We didn't actually use them, though, yet, but I think we will once we move on to the next part of this question, which is the laptop class. So right here at the beginning, it says we want to create a laptop class. A laptop is a computer. That's the inheritance relationship. Anytime you see that phrase, is a, relating to objects, I want your brain to go, oh, inheritance is going on here. Specifically, this class is inheriting from this class. So laptop will be inheriting from computer if this statement makes sense. Where did the... Okay. So the first thing we actually need to do is specify that inheritance with the extends keyword. So if you see this phrase, that means inheritance is in use, and you should be checking to make sure that this extends keyword is there to reflect that inheritance relationship. I'll be honest with you, sometimes I fill this in for you. Other times I ask you to do it. You just need to check and make sure it's set up properly. For a laptop, we can see that the main difference is that laptops have the ability to open and close. So, I have a desktop at home, like a gaming computer, right? You can't open and close those. They just are on or off, or they're asleep. But laptops can open and close, and that also affects the mode that the computer is in, right? So we're gonna try and reflect the fact that it's open or closed, and we need an instance variable to track whether the laptop is currently open or not. That's the only instance variable you've specifically been asked to give. What type are we thinking? Laptop is open or not? That should be a Boolean. Yeah, either it is or it isn't, right? Is open. How many instance variables does this laptop class have? Total. 3, yes. 3. The one that I just wrote here and the 2 that it inherits from the computer class. Yes. We inherit all of the instance variables. So there are 3, and that's important because when we write the constructor, we have to make sure all 3 of those instance variables get set. This one says, when a laptop is first created, it should be closed. So actually, I still think we don't need any parameters. We are using inheritance here. Anytime you're writing a constructor and using inheritance, you need to call the constructor of the base class. And the way that we do that is using that word, that keyword we saw talked about earlier, super. So super followed by parentheses. Now, whether you need to put anything in the parentheses or not depends upon the constructor, right? If I, whoa, what did I do? I don't know how I did that. Hold on a second. Let me fix this. Hopefully. Oh, okay. Never mind. It just made it worse. There we go. I fixed it. Yeah, so if the constructor of the base class does not have any parameters, like we see here, there's no parameters here, then the super is not going to have any parameters. If the constructor of the base class does have parameters, then when I use super, I need to make sure there are parameters here, right? And that might mean that I need to take parameters into the laptop constructor so that I can pass them along to the base class if I need to. In this case, that's not something we have to worry about. So we'll call super. That takes care of the two instance variables that have been inherited. We just have to take care of the last remaining instance variable, this one that's called is open. So I'd say this dot is open, and it says that all laptops start out closed, so I'll just say it's false. Right? All laptops start out as closed. And now we have a couple methods here, one called close and one called open. I think, in a basic sense, these should obviously set the instance variable to the appropriate value. But also, notice that it says it should put the laptop to sleep if it is on. So not only are we closing the laptop, but we're changing the mode of it if this dot is on. Oh, now wait a second. What's the problem? Trying to refer to this instance variable, but it's angry at me. What's the problem? Yeah.
It's a scope issue.
It's a scope issue. It's one that's specific to inheritance in our case. This instance variable is declared here, and it's declared private, meaning we can't access this instance variable outside of this class, outside of this file, unless we use, what's the solution? Just gotta scroll down a little bit, yeah. A getter or a setter, yeah. So down here we see I provided you these getters and setters. This is the moment for you to use them. So instead of saying, accessing the instance variable, we have to access those instance variables through the methods, which in our case is just putting some parentheses on the end. That's the only difference. All right. If it's on, then we need to put it to sleep. We have a similar issue. I can't say this dot, is asleep equals true because I can't access this instance variable. But if I go back to the computer, you'll see that, oh, there's a setter for it. There's a setter for this instance variable. So, okay, I can come back here and say this dot set is asleep to be true. We close the laptop. Set asleep. Sorry. Not set is asleep, but set asleep to be true. And it's going to be a similar story for when we open the laptop up. In fact, I'm just going to go ahead and copy this code right down here. Oops, that didn't work very well. What happened? Right down here, and set this to be false. If the laptop is off and you open and close it, nothing happens, right? Who cares? Who cares? It's still off. But now let's talk about pushing the power button. I know this does vary from computer to computer, but my power button's right here on the keyboard, right? If my laptop is closed, I can't push it, right? I can't push the power button. I can't turn my laptop on if it's closed all the way. It's not possible. So we want to kind of rewrite how this works. This is an example of doing what? What's that term again? It's an override. Yes, this is an override. We are overriding the push power button method. It says, if the laptop is closed, we can't push the button, so we should do nothing. If the laptop is open, we just want to do the normal behavior that pushing the button normally does. And we can accomplish that by calling the method from the base class. So, okay, now we have an idea of what we're trying to accomplish. I can say if this dot is open is equal to false, I have nothing to do. Actually, maybe I should say that the other way. If this dot is open is true, then I just need to call the method from the base class. How do I do that? Super dot push power button, and I'll just take this value and pass it right along. This is it. If the laptop is closed, if this dot is open is false, it's just going to skip it and not do anything, which is what we want, right? Can't push the power button if the laptop's closed. If the laptop is open, then I will just let the power button behave the way that it normally does, using the code from the base class. I believe we have completed this inheritance problem. Does anybody have any questions about this particular problem? Anybody have any questions? Yeah.
For the new push power button, would we need to write in override somewhere?
You don't actually have to state it. You may have seen this in some of the prior examples, this little @ override. It's not necessary. I do think it's handy. It's definitely a nice visual cue for me to look at this and be like, oh yeah, I'm overriding a method from the base class. That is good info for me, but it's not required. So not something that I'll be expecting you to write down on the exam. Good question. Any other questions about this problem? Yeah, in the back.
For the last line, that's a super push power button long press. Are you putting like long press instead of like true?
Well, so the idea is I'm pushing the power button on the laptop, and it should work the same as it would for any other computer. So here, I'm just taking the press that I'm trying to do on the laptop and passing that info. So if this is true, then this will also be true, and I'm just calling the method from the base class to take care of the rest of the stuff. Does that make sense? Any other questions on this problem? Not seeing any. We do still have about 20-ish minutes left, 25 minutes left. Does anybody have another problem they would like to see me work through? Yeah, I promised I'd go to you next. Yeah. Question number 1 for code writing? Be happy to. All right. So for this one, we're making a dormitory class to represent the dorms, and here's that list of hasas again. So I hope your brain is going, instance variables. Here comes the instance variables that Professor Shook wants. Actually, I already gave you the instance variables here, so not as crucial for this problem, but okay, every dormitory has a name, and then every dormitory is going to have a mapping of room numbers to students, and I know that this is not true, but for the purposes of this particular problem, we're going to assume that each dorm room can only hold 1 student. I know that's not accurate. Could we make this, reflect multiple students in one room? Yes, but that's more complicated than I wanted to get into on this particular problem. So we're going to make a simplification here. Assume that every dorm room just holds 1 particular student. All right, we've been given the instance variables, and pay attention to the fact that this is a map. So when you see a map, here we have our angle brackets. This first type is the type of the key, and this is the type of the value. So this is going to be a room number, and this is going to be the student that's living in that particular room. That's the idea. Okay, we need to first write a constructor. Oh, surprise, surprise. That's been like the first thing that we do in almost all of our objects, right? Declare instance variables and write a constructor. So, all right, public dormitory. For full credit, it says we should only use one parameter, so think about what that means. Which of these two values are we going to accept as a parameter, and which of these do we say is some known value? We'll pretend you're one of the construction crew for a moment. I build a brand new dormitory. How many people are in it? None. It's empty, right? Nobody lives in it when I first create my dormitory. It is empty. It is empty. So I think the name is the one that we should bring in as a parameter. And notice I did that same thing that I was talking about before, where this has the same variable name as this, but these are two separate variables. I hope everybody understands that fact. This variable is coming in as a parameter to the constructor. This is an instance variable. They happen to have the same name. That's allowed. I can have multiple variables with the same name, but we have to be careful when doing something like this. This is ambiguous. This is wrong. But if I want to clarify, remove that ambiguity by specifying that, oh, I want this to be an instance variable, I can put this dot out in front, and now it's not ambiguous anymore. This refers to the instance variable, and this one refers to the parameter. All right, what about our other instance variable? We still have to make sure this gets set to be a proper value, and this is something that is commonly missed on this exam for these kinds of problems. Hash maps and also lists, because this, that was the other data structure we saw, was a list. They are objects, and in order to use them, we need to construct them. We need to create instances of them. So if I want to reflect the fact that this is an empty dormitory, okay, I still need to construct this empty hash map. I still need to call the hash map constructor. And the way that we would do that is, well, what you tell me. What's the first thing that I type out when I try to call the constructor? It's a three-letter word. New. That's right. Anytime I want to call a constructor, I first start with new. Then I type the name of the thing I'm trying to construct. I'm trying to construct a hash map. Because this is a map, a data structure, we are obligated to put these brackets. However, notice that I don't actually have to put anything in these brackets. You can. If you wanted to put something in these brackets, you would put this inside of them. But you don't have to. And then the last thing that we do need to do is put the parentheses, because we're calling the constructor, which is a method. And all method calls require parentheses. So I know this looks a little silly. This is kind of what I was talking about last week when I talked about lists and maps. But all of these pieces exist for a reason. This exists because it's a container. This exists because we're calling the constructor. This is how we call the constructor for the hash map. And this is necessary. This is necessary. One good way of thinking about this might be a good thing to put down on your sheet, right? If one of my instance variables is a list or a hash map, I still need to say, this dot something something equals something, where I'm calling the constructor there. That is a very common way of handling it. Any questions about this before we move on to the other methods of this problem? Yeah.
Are we almost always just going to use hash map to start with?
Are we always going to use hash map to start
Yeah.
with? I'm not sure I understand the question.
Well, can't you also just do like map? Is that different?
Oh, I see. I didn't explain this in a whole lot of detail, but there's more than one kind of map. So a hash map is one kind of map. There are multiple others. Tree map is another common kind of map. We didn't get into the differences. That's more of a 247 problem than a this class problem. But the reason why you see me type map somewhere and hash map other times is because of the fact that there are more than one map. But to get back around to answer your question, what kind of map do we use in this class? Hash maps, yes. Could you use a tree map? I mean, I suppose if you really wanted to, but it would be a little weird because that's not the kind of map we use in this class. I would expect you to just use a hash map. Usually I'll make it very clear by just telling you directly. Yeah. All right, some of these are just getters and setters, so those are easy, right? Here's a getter for the name, so we can just say return this.name, and that one's a done deal. Get occupied rooms. All right, so now here's where we have to start to think a little bit. The rooms is based on this map. So if I want to know how many rooms are occupied, I have to figure out how many things are in this map. And this is where that reference sheet on the exam is going to come in handy, right? There is a method called size that tells me how many things are in the map. And that should, in this case, represent the number of rooms that are occupied, right? There's going to be one entry in the map for every room. If there isn't a student in that room, then I'm just going to not expect to see them there necessarily. For adding a student, they want to take this student object and put it into this room number. I kind of just said what the answer is, right? To get things into a map, the appropriate method is the put method. So I'd say rooms.put. And, oh, Eclipse is smart enough to fill in for me. That's exactly right. I want this to be the key and this to be the value. That will associate that student with that room number. All right, now we're asking, is this room occupied? So I give you a room number and I want you to tell me whether there's a student in that room or not. What if there isn't a student in that room? If I go to a map and I say, tell me who's in room 204, and there isn't a student in that room, the map is going to say to me what? I say, tell me what student's in this room, and there isn't one. The map's going to say, what is that word we use when there's an absence of something? Yeah. Null, yeah, that's it. That's the one. So if it's not in the map, if there is no student, don't know who's in that room, it's going to give me back null. So actually, we can use that to help us here. If the value is not null, I know that there's somebody in there. I don't care who it is. I just want to know if there's somebody in there or not. So if the answer is not null, then it's occupied. If it is null, then it isn't occupied. So I think that we could just say return rooms.get room number. So we want to know if it is occupied. That would be occupied if it's not equal to null. So we can just check this directly. I think there's another way that you could do it as well. So this isn't the only way to do this. I think there's also a method on your sheet. Actually, here it is. Contains key. Contains key. So the room number is a key. Contains key tells me whether a certain key is in the map or not, right? If the key is in the map, then that room must be occupied. If it's not in the map, then nobody's in that room. This would also work. I would accept both of these answers. I think they're both good answers for this part. And now down here, we've got this problem that wants us to get a list of all student IDs of students who are in this dorm. So this is definitely the trickiest one, definitely the trickiest part of this problem. First off, look at this return type. Hopefully that doesn't scare you too much. We've returned arrays, right? So it shouldn't be surprising that I can also return a list, a linked list. And just like problems that return arrays, the first thing that I'm going to want to do is probably create a new one, right? So usually we would create a new array to hold our results. The same thing's going to be true here. I'm going to want to create a new list to hold my results. So we need to call the linked list constructor. I'll call it IDs. Oops. And I forgot the angle brackets over here, right? I need to say it's a linked list of integers. That's the kind of stuff that I'm putting in the list. Now I can finish calling the linked list constructor. So this is just an empty list that I'm going to use to hold all of the student ID numbers that I can find. We now have to go through the map and find all of the students who are in it, but that's a little tricky because the students are the values, right? And I can't access those values directly. I have to access them through the keys. I actually showed you two different ways to iterate through a map last week, so this would be a good time to refresh your memory on those particular examples down here. I showed you two different ways to iterate through a map last week. The big takeaway that I talked about was that it requires a for each loop. If you want to iterate through a map, it requires a for each loop. This is probably my preferred way to do it. This is a for each loop that will iterate through all of the keys of the map. If I want to get the values, I can simply plug the key in to get the value back out. So if we apply this to our situation for the problem that we're currently working on, I need a for each loop. In this case, the key represents a room number. I'm going to get those from all of the keys of my map, and this is another thing from the reference sheet where there is something called a key set. It's actually the same thing that I just showed you in that example right here, grabbing the key set from a map and iterating through it using a for each loop. We now have all of the keys inside of this for each loop. So if I want to get the student back out, living in dorm equals rooms.get, and we'll plug in the room number. Okay, but this is an object, right? This student is an object, and I wish to get the ID number from this student. So this is another place where people make mistakes on this exam. They think that if you just call this, that's going to give you back the ID number. No, actually, it's going to give you back a student object. The ID number is in there. It's in that student object. But you then have to take that extra step to get the ID number back out. So to get the actual ID number, we need to call the getter upon the student instance. By calling getID on that student object that we just retrieved from the map in the previous step. Once that's finished, we can add that to our list of IDs. And now we're done with this problem. Our final step is to return our completed list. This one is definitely, I think, the trickiest one as part of this problem. Does require you to iterate through a map, but I did give you that example. That is, I think, one of the more common things that people put on their cheat sheets is how to iterate through a map, because it does require a for each loop. You cannot do a for int I equals 0, right? And to understand why, consider there is no index 0, right? Maps don't have indices. Arrays do. Lists do. So if you want to use that style of loop to iterate through arrays and lists, that's perfectly okay. But for a map, it doesn't make sense. There is no index. There is no 0, 1, 2, 3 kind of thing happening. So we use a for each loop to do it instead. And then the last part of this problem actually is down here in the main method. I think this is a great way to wrap up our review session. It says create an instance of the dormitory class and store it in a variable. So create an instance. I really, really hope there's alarm bells going off in your brain right now. Creating an instance. That means I need to call the constructor. Got to call the dormitory constructor. Well, that's right up here. We wrote the dormitory constructor just a few moments ago. So in order to call it, I'm going to make dormitory dorm equals new dormitory. And I have to give it a name, right? I have to give it a name. I've never actually stayed in the dorms here, so I'm not quite sure I'm up to snuff on what all the names of the dorms are. Isn't there one called, I don't know. Doesn't matter. Fancy dorm building place. That's the next name of the dorm that Washu is going to build for us on the 40. But that's it. That'll call the constructor. On the exam, I don't care what you call it. People will often use their own, like, I don't care what you call it. I don't care the name. What I'm looking for on this problem is, do you know that you need the new keyword? Do you know how to call the constructor? Does it have the appropriate number of parameters? Because you wrote the constructor, right? If you write the constructor up here and it only has one string parameter, then there better only be one string parameter down here too, right? Next, it wants us to create an instance of student and add it to the dorm. We get to pick which room to add it to. Okay. Student S equals new student. This is the same student object that you were working with on assignment 7. I actually don't remember the constructor for this one. Oh, it just needs an ID number. I mean, okay, actually not the same one then if all it needs is an ID number, because the one on the assignment was a little bit different than that. It required you to put in a name as well, so not exactly the same. But once you have your student object, in order to add it to the dorm, we need to use the appropriate method on that dorm instance. So dorm.addStudent, dorm.addStudent. We need to specify what room number we're going to put them in. I just keep using 204 because that's my office number, and then S is the student. And then last but not least, this one is also kind of tricky. Write code to determine if a student with this ID number is in the dorm using the appropriate method. So first, I need to get a list of all students' ID numbers that are in the dorm. Well, wait, we have a method for that, right? So here's another important point to keep in mind. Even if you think you botched this answer, right? Maybe you think this code doesn't work. It doesn't matter. You still know that this should return a list of student IDs. So call this method appropriately. Who cares if this doesn't work? That's a separate problem. We can still call this method appropriately to get the list of student IDs. So, and you could do this all in one line. I'm actually kind of debating if I should do it in one line or two. I would say no, I'm going to do it in 2 lines, sorry. I almost did it in 1. If you did it in 1, I wouldn't complain, but I'm going to do it in 2. First, I'm going to get the student IDs list. This list can very easily tell me whether it has a value or not because there's a method called contains. So I would just need to say IDs.contains 1, 2, 3, 4, 5, 6. I think this should probably be an integer, I guess, to be, yeah, there we go. That's what it was unhappy about. So get the list of student IDs from the dorm, and then ask if that list contains the dorm number that you're looking, or the student ID that you're looking for. All right, that was a lot. Any questions on any part of this problem at all? I'd be happy to go back through any part of it if you would need me to. Okay. I don't think I'm going to have time to go through any more coding problems. We only have just a few minutes left in class, but I will stick around. If you have any additional questions, feel free to come on up and chat with me after class. I also have another review session starting at 2:30, so if you want to stick around and review more objects, we'll probably end up doing some of the same problems, but we might do some different problems. You're welcome to stick around if you want. Otherwise, I will see you, if not in the labs on Wednesday, I'll see you at the exam on Thursday nights. Have a great week, everyone.